Hello guys, welcome to my YouTube channel. In this channel, we'll be discussing everything you need to know about solar energy, both the installation and everything that revolves around solar energy. Please, before you get into the video, please do well to like, share, and subscribe to my YouTube channel. Turn on your notification button so you'll be notified when I release new videos. Today we'll be doing our solar 101, Introduction to Solar Energy. After watching this video, you will have a deep understanding about solar more than the average people. Then let's get into the video. Solar energy is the energy derived from sun radiation. This solar energy can be harnessed with two technologies. The number one technology is the use of photovoltaic panels. Photovoltaic is derived from two words: photo, which means light, and voltaic, which means electricity. So photovoltaic panels are those panels that convert light energy from the sun to electricity using photovoltaic effect. Then we have another technology used in utilizing sun radiation, which is called solar thermal system. Solar thermal system use mirrors and collectors to concentrate sunlight to generate heat, used for water heating, space heating, and for driving turbines to generate electricity. Then we move into the major components that make up a solar system. The number one component that make up a solar system is the solar panel. The solar panel is a group of solar cells that is connected in series or parallel, made from a semiconductor material, usually silicon, to convert light energy from the sun to electricity using photovoltaic effects. We have different types of solar panel. The number one type of solar panel we have is the monocrystalline solar panel. The monocrystalline solar panel are those types of solar panel that is made from single continuous crystal of silicon. The monocrystalline solar panel are black or dark in color. They have between 18 to 24% efficiency. They work well in low light condition and are also space efficient. Then we have the second type of solar panel, which is the polycrystalline solar panel. The polycrystalline solar panel are those solar panel that is made from multiple crystals of silicon. They are slightly less efficient than the monocrystalline solar panel. They have between 15 to 18% efficiency. They are blue in color. Then we have the third type of solar panel, which is the thin film solar panel. Thin film solar panel is made from materials like cadmium telluride or amorphous silicon. Thin film solar panel are lightweight and flexible type of solar panel. They have high degradation rate and have shorter lifespan. They are used in areas where space is not an issue. Then we move into the second component of the solar system, which is the inverter. The inverter converts the DC electricity from the solar panel or from the battery into the AC electricity that we use in our homes, houses, factories, business places, and so on. We have three types of inverters. Number one is string inverter. The string inverter are also known as central inverters, are those kind of inverter that is mounted on the wall and have a whole array of solar panel connected to it. Under string inverters, we have hybrid inverters and non-hybrid inverters. Hybrid inverters are those type of string inverters that have inbuilt charge controller inside the inverter. Then the non-hybrid is the one that doesn't have inbuilt charge controller inside the inverter. Then the second type of inverter is the micro inverter. Micro inverter converts DC electricity from the solar panel to AC electricity at the roof level. So with micro inverter, you don't have high DC voltage running on your roof or your ground mount. The micro inverter also helps with shading and complicated roof, so that when one panel is shaded, it doesn't affect the output of other panels. It also helps with panel level monitoring, so that you can monitor each panel independent of each other. You can monitor the production of each panel. Then we go into the third type of inverter, which is optimizer based system. For optimizer based system, you have a string inverter mounted on the wall and have a DC optimizer mounted under each panel to give each panel level monitoring, so that you can monitor each panel independently, and also helps with complex and shaded roof, so that when one panel is shaded, it doesn't affect the output of other panels. Then we move into the third component of the solar system, which is the solar charge controller. The solar charge controller regulates the voltage and current from the solar panel going into the batteries. So the solar charge controller avoid a deep discharge of batteries and overcharging of the batteries. We basically have two types of charge controller. The PWM charge controller, which stands for pulse width modulation. PWM charge controller regulates the width of electrical pulses of voltage and current from the solar panel going into the battery. For a PWM charge controller, excess voltage is a waste. Let's take for example that we have a 12 volt PWM charge controller with a 12 volt battery, and we have a 20 volt solar panel. The 12 volt PWM charge controller will collect 14.4 volt to charge the 12 volt battery, and excess voltage from the solar panel now goes to waste. For a PWM charge controller, the voltage of the solar panel must definitely match the voltage of the battery. PWM charge controller have a lower efficiency, between 65 to 75% efficiency. Then we move into the second type of charge controller, which is the MPPT charge controller. MPPT stands for maximum power point tracking. MPPT charge controller tracks the maximum power point of the voltage and current for the solar panels going into the battery. For MPPT charge controller, excess voltage is converted to current to charge the battery faster. And MPPT charge controller have a higher efficiency, between 95% to 98% efficiency. They have other functions like equalization. MPPT charge controller are more expensive than PWM charge controller, but they can offset their cost over time due to their ability to draw more power from the solar panel to the batteries. Then we have the fourth component of the solar system, which is the batteries. The battery is an energy storage device that stores excess electricity from the solar panel or from the grid for night use or for bad weather. We have two major battery technologies using solar energy. Number one battery technology is the lead acid technology. Under lead acid technology, we have the flooded lead acid battery. The flooded lead acid battery are those type of lead acid battery that have liquid electrolytes. They are type of lead acid battery that requires maintenance, such as equalization, topping up with distilled water when necessary, and cleaning up the terminals of the battery when acid settles on it. We have another type of lead acid battery, which are the gel and the AGM battery. The gel and the AGM battery are the maintenance-free lead acid battery. They don't require any maintenance. The gel and the AGM battery have a shorter lifespan compared to well-maintained flooded lead acid battery. The gel and the AGM battery cannot handle high charge and discharge rates, unlike the flooded lead acid battery. We go into the second technology of batteries using solar energy, which is the lithium batteries. Under lithium batteries, we have the NMC batteries. The NMC batteries have a high energy density compared to their size, and that's why they are used in electric automobiles like electric cars, electric bikes, and electric scooters. They are more prone to fire outbreak. They also have shorter lifespan, and they have charge cycle between 3,000 to 4,000 charge cycle. Then we move into the second type of lithium batteries, which is the lithium iron phosphate battery. The lithium iron phosphate battery are more safer to use, they are more durable, they are more thermally stable, and have a longer charge cycle between 3,000 to more than 8,000 charge cycle. They have smaller energy density compared to NMC batteries. Then we move into the fifth component of the solar system, which is the mounting structure or the racking. The mounting structure or the racking is the frame or support that keeps the panel in place on the roof or on the ground mount or the pole to make sure that the panel doesn't move or avoid the panel being blown away by wind. This racking or mounting structure is mostly made with aluminium or galvanized steel. Then we move into the advantages of solar energy. The number one advantage of solar energy is that solar energy is environmentally friendly, so that solar energy doesn't emit any harmful gas to the atmosphere, unlike the diesel generators that emit carbon monoxide to the atmosphere, which is harmful to our environment. Solar energy doesn't emit any harmful gas to the atmosphere. The second one is that solar energy increases energy independence. Solar energy reduces our reliance on the grid or the use of petrol or diesel generators. So it increases our energy independence, that you can decide to go off grid and run all your appliances and your gadgets from your solar energy setup. Then the third one is that solar energy is a reliable and inexhaustible source of energy and can always be replenished. Then the fourth one is that solar energy creates jobs for the growing population. Increase in adoption of solar energy have created jobs in installation, manufacturing, and maintenance of solar energy systems. Another one is that solar energy is a silent producer of energy. Unlike diesel generators, which make a whole lot of noise during its operation, solar energy runs more quieter and doesn't produce much noise during its operation. Then the next one is that solar energy requires low maintenance after the installation. So unlike diesel generators that requires frequent maintenance for it to operate properly, solar energy, once installed by a qualified personnel and quality product is used for the installation, solar energy requires very low maintenance. Then we move into the disadvantages of solar energy. The number one disadvantage of solar energy is that solar energy is intermittent. Solar energy depends on the sun, which varies by the time of the day or the weather condition. Sun doesn't shine throughout the day, and the sunlight is not always available, so it's intermittent. The second one is that solar energy have high initial cost, such that procuring solar energy equipment like inverters, charge controllers, solar panel, batteries, and cost of installation is expensive. So solar energy have high initial cost. Then the third one is that solar energy is space dependent, so that most especially for large installation, solar energy requires enough space on the roof or on the ground to mount your solar panels. So if you are going for a large solar energy setup, it requires a whole lot of space for you to mount your panels. Please, if you can drop on the comment section the kind of video you want me to do next. Please, if you find this video useful, please do well to like, share and subscribe to my YouTube channel. Turn on your notification button so you'll be notified when I release new videos. Thank you very much.